Hello everyone. In this video tutorial, we will study the inverse Laplace transforms. To begin with, we will go through a few formula to evaluate inverse Laplace transforms and then solve problems related to these formula. We will start with a few standard formula. We've already studied Laplace transforms, and inverse Laplace transforms look something like inverse of the Laplace transform. You can visualize a function and its inverse Laplace transform. To find the Laplace transform, we will look at the second column over here. Laplace transform of 1 was 1 by s. Similarly, the inverse of 1 by s will be 1. Laplace transform of t was 1 by s square, so that the inverse Laplace transform or L inverse of 1 by s square will be t. L of t square was 2 by s cube, so that to find the inverse Laplace transform of 1 by s cube, the 2 goes over here. Inverse Laplace transform of 1 by s cube is t square by 2. In general, if we have 1 by s power n, it would be a power lesser here. S cube, it became t square. So if it is s power n, this will be t power n minus 1 by n minus 1 factorial. What is the power of t? The same factorial will come as the denominator. L of e power kt was 1 by s minus k. Similarly, L inverse of 1 by s minus k will be e power kt. L of cos at was s by s square plus a square. So L inverse of s by s square plus a square is cos at. Similarly, L inverse of a by s square plus a square sin at. L inverse of s by s square minus a square, that is cos h at. If there is a plus, that is the trigonometric function cos, it is minus, like in the next formula also, the function is hyperbolic cos of h at, and this is sin h at. With these formula, we'll proceed to solve a few problems. The first problem, find the inverse Laplace transform of s by s plus 4 whole square. That is to find the L inverse of s by s plus 4 whole square. We'll go back, we'll check if any formula is applicable. S by s plus 4 whole square, this is like the form a plus b whole square in the denominator. S by is there, but there is no a plus b whole square format. I have only a square plus a square. So that this I will have to convert it to the form a square plus a square, or we'll have to do some other trick. What we'll do now is, we'll start with s by s plus 4 whole square. I will add and subtract 4 here so that I can split the fraction. We will add and subtract 4. We can split the fraction here. S plus 4 by s plus 4 whole square minus 4 by s plus 4 whole square. 1s plus 4 gets cancelled, so that I have L inverse of 1 by s plus 4 minus 4 by s plus 4 whole square. We will split the inverse function like we split the Laplace function. L inverse of 1 by s plus 4 minus, that 4 is a constant which can be taken outside, so that it becomes L inverse of 1 by s plus 4 whole square. Now, which formula to apply? This looks simple. This is of the form 1 by s plus If 1 by s minus k, then it becomes e power plus kt. If it was 1 by s plus k, then it will become e power minus kt. So that this is clear for us. This is of the form 1 by s plus k. So that it is e power minus 4t. Minus 4 is already out. Now, clearly look at this term. 1 by s plus 4 whole square is of the form 1 by s square except for this plus 4. So what we will do now is, we remember the shifting property in Laplace transforms. In the same way, here also in the inverse we can apply the shifting property. If this plus 4 was not there, it was of the form 1 by s square. If it is 1 by s square, then the inverse is t. Okay, so 1 by s square becomes t, but this plus 4 with the s indicates a shifting. If it is plus 4, then the shifting is e power minus 4t. So 1 by s plus 4 whole square, will apply the formula first for 1 by s square, which is t, and this plus 4 we will take it as the shifting property of the function, that plus 4 becomes e power minus 4t. So altogether, taking the e power minus 4t common, this becomes 1 minus 4t. This is the answer. This is the solution for this particular question. We'll move on to the second problem. The function to find the inverse Laplace transform is 1 by s minus 4 whole cube. This is cube here. So n inverse of 1 by s minus 4 whole cube. Now again, this would have looked like 1 by s cube except for this minus 4. If it is 1 by s cube, 1 by s cube, then by formula, that is t power 1 less than this, that is t square, divided by the same factorial. So that 1 by s cube, L inverse of it as t square by 2 factorial. If I ignore this minus 4, this is 1 by s cube, so that it becomes t square by 2 factorial, which is 2. This minus 4 will give me a shifting property, so that minus 4 will give me e power plus 4t dh half into e power 4t into t square, which is the simple solution here. Let's move on to the next problem. Hope you all understood the trick when we use the shifting property. Third one looks a little bigger. L inverse of s plus 2 by s square minus 4s plus 13. Now this does not look like anything what we have in the standard formula. Numerator we can handle later. Our denominators have only s square plus a square or s square minus a square, so that I don't have this kind of term in any standard formula. So we'll take this term and we will try to complete the square. A square minus 4s is there, so a square minus 2ab format is already there. I need a b square over there. So what we will do, s is a here because the square is there, s becomes a. This we will split minus 2ab minus 2 into 2. So that 2 becomes my b, so that I will separate a b square, that is 4, from this 13, so that what is left is 9. 9 plus 4 is 13 for us. So these three terms together will give s minus 2 whole square plus 3 square. So that L inverse of s plus 2 by square minus 4s plus 13 is L inverse of s plus 2. Substitute this term, s minus 2 whole square plus 3 square. This is of the form s by s square plus b square, except for this plus 2 and minus 2. So what shall we do now? We'll come back here. Probably we have a shifting sign. if there is a shifting, then it would be s plus 4, s minus 4, such kind of terms. If a shifting is done with this s, the same shifting will be done with this s also. So if there is s minus 4 here, there will be s minus 4 here. There is s plus 4 here, there should have been a s plus 4 here. What happened to our problem here? We have s minus 2 here, but s plus 2 here, so that I cannot apply the shifting property directly. So we'll make it as minus 2. If I have to make it as minus 2, add and subtract 2, so that minus 2 I can combine together, and 2 plus 2 becomes 4. So L inverse of s minus 2 plus 4 by s minus 2 whole square plus 3 square. Shift the inverse, this term, plus L inverse of 4 by s minus 2 whole square plus 3 square. The first formula goes with the shifting property of the form s by s square plus a square. Inverse of s by s square plus a square is cos formula. Cos a is 3, so cos 3t. The shifting of minus 2, so that it is e power plus 2t plus. Now this is also of the form s square plus a square in the denominator, but there is no s or a in the numerator. Either I should have s by a square plus a square or a by a square plus a square. I cannot add a s here, so what we will do is we'll convert in the form of a by a square plus a square. A is 3, a square plus a square, a is 3. I have to put a 3 over here, so multiply and divide by a 3. Then apply the formula here, so that a by a square plus a square, that is sine at, a is 3. There is a shifting of minus 2 here, so that I can have to include e power 2t. Altogether, I can take e power 2t, e power 2t common, so that e power 2t into cos 3t plus 4 by 3 sine 3t. Okay, I will continue the fourth problem. L inverse of s plus 1 by s square plus 2s minus 8. This is similar to our previous problem. There is a quadratic polynomial in the denominator. It is not of the form s square plus or minus a square. So obviously we will have to complete the square. S square plus 2s. What we have to do is identify the term I have to separate from this minus 8. This is s square plus 2ab. 2 is there, a is s. There's nothing for b, that means b must be equal to 1. If b is 1, we will separate plus 1 minus 1, plus 1 minus 1, and this minus 8 as it is. Plus 1 I require it for the square, so that minus 1 minus 8 becomes minus 9. These three terms together of the form a square plus 2ab plus b square, that is s plus 1 whole square, this 9 becomes 3 square. So that substitute in my question. S plus 1 by s plus 1 whole square minus 3 square comes in the denominator. Now if you look at the terms with s, this is s plus 1, this is s plus 1. So this looks like s by a square minus a square with a plus 1 shifting in s. So I can apply the formula directly of s by a square minus a square, that is cos h at a is 3 here. Because of this plus 1, we have a shifting of e power minus t. Plus 1 gives me minus 1t. So that solves this problem. We move on to the fifth problem. L inverse of 3 plus 4s by 4s square minus 16. Denominator is a quadratic polynomial. There is a square. There is a minus a square also. Minus 16 can be considered as minus 4 square, so there is a square minus a square, but there is a 9 extra here, so that I have to separate this 9 from a square. We'll take this 9 common. When I take 9 from both the terms, from the first term 9 comes out, from the second term it comes out as by 9, 9 and 9 got cancelled. I can take a constant outside, 1 by 9 comes out as 1 by 9. L inverse of 3 plus 4 is by a square minus, I'll convert this into a square representation, 4 by 3 whole square. So denominator is set a square minus a square, but with the numerator L inverse of 3 with this denominator plus 4 can be taken outside, along with this 1 by 9 it becomes 4 by 9, L inverse of s by s square minus 4 by 3 whole square. Second one looks like a standard formula, s by s square minus a square with the first one, 3 by s square minus 4 by 3 a square. Denominator is of the form s square minus a square, but there should be an a here also. Instead of a, 4 by 3, I have only a 3. 3 should be in the denominator. The 3 comes as the numerator here. So I'll have to put a 4 by 3 here. Remove this 3. I have to move the 3 outside. 3 by 9. We'll put a 4 by 3 here to balance this 4 by 3 and multiply by 3 by 4. So that is 4, 4 and 3, 3 would have got cancelled and 3 would have been in its original place. Since for 4 by 3, I have balanced it with 3 by 4 here. Now this is of the form, this is my a. A by a square minus a square. There is no problem with this term. We'll apply the inverse Laplace formula here. 3 3s are 9, which gets cancelled with this 9 here, so that I have a 1 by 4. L inverse of 4 by 3 by a square minus 4 by 3 whole square plus the second term as it is. 1 by 4 a by a square minus a square. Because of this minus, I have a hyperbolic sign. Sin hyperbolic a square by 3. Sin h a 2. There's no shifting done with s. It is as it is a square. Again, the second formula. There's a minus here, a square minus a square, so it is hyperbolic cos s by a square, so that it is cos hyperbolic 4 by 3t. So this is the answer for this problem. A similar problem, the sixth one, I think you can go through this problem and try to solve this. Solution is already given. All we have to do is take the denominator, complete the square, a square minus 2s, so that this becomes a minus b whole square form. So that complete the square. And when I complete the square, I have s minus 1 whole square plus 3 square. What we normally do is we split the terms into 2s and 1. But there's a problem with the denominator. Either I should get the formula as s by a square plus a square or a by a square plus a square. So if I have to put it as s by a square plus a square, then my s should be in the form s minus 1, because in the denominator I have s minus 1. Both the numerator and denominator, if there is a s, should look same. So this 2s minus 1, what we have to do is we have to convert it into s minus 1 form. So this 2s minus 1, I have mentioned the working here. There is a 2 into s. So what I'll do is, if I have to make it as s minus 1, I'll take this 2 common and make it as s minus 1. So that for this 2s minus 1, I'll add and subtract a 2. This minus 2, I will keep it with 2s. And this minus 1 and plus 2 becomes 1. From this 2s minus 2, I'll take a 2 common, so that this becomes s minus 1 plus 1. So doing all this, my numerator 2s minus 1 is 2 into s minus 1 plus 1. And we will split the inverse Laplace transform. So this is 2s minus 1 comes in the first one, plus 1 comes in the numerator of the second term. And this 2 I have taken outside. So 2 into L inverse of s minus 1 by s minus 1 whole square plus 3 square plus L inverse of 1 by the same denominator. Now my s looks same, numerator and denominator, it is s minus 1, so that it is of the form s by s square plus a square, that is plus, then it becomes cos 80, a is 3 square, so cos 3t, with a shifting of minus 1 so that I have e power plus 1t. Similarly here, 1 is not allowed in the numerator unless 1 is here. A by s square plus a square. A is 3 actually, so this 1 will not work. So if it has to be a by s square plus a square, then this 3a must come over here. So we'll multiply and divide by a 3 so that this and this a by s square plus a square should be same. So if it is a, then my formula is sin 3t. Simplify all this. 1 by 3 is as it is, s minus 1 so that I have a shifting of e power plus t. Take e power t common, 2 cos 3t plus 1 by 3 sin 3t is the solution for the sixth problem.
More problems we will continue in the next session.